I switched on my microphone. I hope I can be heard. Can I be heard? Yes, very good. Since the mic is behind my back, I don't know whether I actually switched it off. It's a binary switch, but I can't see it. Anyway, so we made it through a first idea of what is science and the way we organize homework. Part of the excitement, I think, of this course is that you can also take a project. So here are what we mean by that. It's the 5 additional ECTS you can get towards your degree program's goal. What you'll be doing is performing a small research project with, for a scientist, the proper output of a research paper, which has certain structure. We'll see that in a bit. And where the work towards that research paper is structured in these steps. First an outline, then the so-called related work, meaning what's already out there, what has been done, to which you relate your research question because you don't want to repeat what someone else has done already. Contributions, and then the writing. Contributions meaning doing the legwork of science, doing the applying a research method, and then writing the final paper. Like with the homework, we enforce a certain work rhythm. The reality is that if we don't ask for anything in between, but only for a final paper at the end of the semester, a non-trivial number of you will start working 1 week before it's due. And the consequence is neither you nor we will be particularly happy with the results. So we want you to make time every week, commensurate with the 5 ECTS, meaning 5 ECTS is 150 hours for the semester. So break that down to a week and make that time and deliver incremental results. At the end, there will be the final deliverable, the actual paper, but we also take note and grade what's in between. So let me do it again. Go back here. It's these steps. So there's the paper outline due in the research question, actually due in 1 week or 2 weeks. 2 weeks later, the related work. 2 weeks later, the research contributions first version, second version, draft, final paper, and on the last day of the course, the paper presentation. So the reason for that is a research paper has a set structure. We will go over how that looks like for everyone because you need to understand the structure of how research work is being presented. But in such a project, you're incrementally learning. So you cannot just sit down, stream your thoughts into the structure, and that's it. Meaning you will actually rework it. You will be able to do some basic structure or content first, and then incrementally evolve it. And so you will be building on it section by section. As you're writing your research paper, you should be using this particular format. That's literally a format of how your headings should look like, of how your text should look like, and use that. That's actually a proper professional format of the ACM that's being used in research worldwide. That research project, we will guide you. We will come to the projects in a second. We will guide you. We will actually pretty actively work with you, which if it was a real scientific paper to be submitted to some journal or conference, would mean that you, as well as us, would be authors. Here we are simulating the experience that you are the sole author, even though we guide you. So you should put only your name on the research paper. And now, online, I have to do it a bit differently. I can't just follow the link here. Who of you would like to do a research project? In the room, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so that's more. And anyone online? Do you see anything, Andreas? Okay, so I believe we have more.
Some of them, yes.
Okay. So I believe we have more project requests than we got initial feedback. We sent out the surveys, so some may not have seen that, asking, do you want to do a project? We will try, I cannot promise, but we will try to make it possible that everyone can do a project. We have a couple of example projects here. These are actual projects that we want to do. Yes, please. You can try to convince us. Most likely the answer is no, because we need to guide you. And so we do it only if it's actually of interest to us as well. So here an example, number of example projects. These are actually real projects. We want to do those. But at the same time, expecting that maybe not everyone answered to us, you can view them as examples and say, oh, SP2, that's what I want to do. And you need to contact us. If that person listed here, for example, if SP2 is what you're interested in, you should be talking to Anne. And then we will sort it out. So that's what I want to do. If we have multiple people for it, we will somehow split it or find something similar. So there's a bit of a discussion between you and us as to the actual projects. Anne, by the way, is sick today. I think she's online, but she's not here. So, but you can converse on chat with her. You can open a private chat. She's here, or send her email. It's anne.barcomb, B-A-R-C-O-M-B. Names to be found on our website if this is of particular interest to you. So let me go here. Yeah, so you can see in the chat her email address and barcomb@fau.de. And she has 2 or 3 projects here and some others. So yes, hers are first. So Andreas, do you want to summarize those, or should I do that? Okay, so Anne suggested 2 projects in line with her dissertation work. The first one is on episodic volunteering. So in terms of content, what it means is in open source projects, meaning these software projects where you get volunteers to contribute to a software project. We find a particular sort of contributor, which we call an episodic volunteer. Most of these projects have sustained contributors who join the project, keep developing for a long time, maybe drop out. Most of the time, these days, these are actually paid for by companies because open source has become solidly commercial. However, there's a subset of contributors who come and go. We call them episodic. So they're there for a few months, perhaps, and then they leave again because they're scratching the itch. The project is not their livelihood or lifeblood. They just contribute and then leave. So for that, Anne would like someone to do a time-honored way of doing research, which is a literature review, which is a systematic review of what is out there in the libraries on the topic of episodic volunteering. And part of that is reading it and building a model, meaning here I think it is mostly seeing the different dimensions in this research work so that we can classify what has already been done with the goal of identifying gaps and holes in current research. I was about to say build a theory of episodic volunteering, but that's too much. That cannot be done typically with this course. But I'm sure if you're ambitious and would be happy to have you go beyond the scope of this year. I believe for every of these topics, someone already signed up. So Anne, raise your, so she can't speak, but she will hopefully tell those people who she already connected to if I just garbled a topic. I hope I explained it well. So the second one is, the second one, you want to talk? Okay, you go ahead. Okay, so the second one is also related to episodic volunteering, but it's about people who apparently hop or jump between projects. So you don't just once in a while contribute to one project, but you really move across projects. So what does that mean as you take knowledge with you from one project to another? And here the outcome would be reading the literature, but then create a hypothesis, some hypothesis, what you find interesting, and also gather some data as to who could be asked in confirmatory research about this hypothesis so that we can learn it's true or false. So this involves also some programming work, I believe, to implement an algorithm to find email addresses from GitHub, for example, where we have the data. And she wants you to go as far as a statistical analysis of that. So then you should also remember your statistics course. Always a challenge, but for a scientist doing confirmatory research, even basic things like hypothesis testing are important. You should hopefully did not all forget about your math courses. All right, on to project 3. I will let Andreas talk, and I try to give him the microphone, if that's possible. I just broke it. Oh, come on. Well, so, I don't know. Do you have a mobile microphone? There you go.
So hi everyone. So my research topic, I believe, is even doubly relevant for this course, since this is a research course, and I'm interested in applying research methods for modeling and software engineering. So there are qualitative research methods for analyzing data that is unstructured and creating something from that is structured, that has that can be formalized more easily. So this SP3 topic that I have here, for instance, we're interested in seeing if qualitative data analysis methods used by social science researchers, for instance, can be used for creating a process model. So a process model in this case of human resource development. Now, in the course of this project, you won't follow the whole research process that would usually you would usually have to follow when doing qualitative research, which is doing interviews and transcribing them and then coding them and creating a theory from that. So we already have parts of that done already, and you could have this material that has already been gathered and then simply analyze it using the methods that we will show and teach you in this course also, and create this model. And then you can, so what's of interest to us from a research perspective now when we apply this research method is, can we use the same data that we use for creating conceptual models, so a structural model of the domain, to now create a dynamic model of the domain, so a process model, which would be derived from the same data with the same method, but with a different perspective in analyzing it. So that would be of interest to us. And using the same data, we could do something else as well, which is written up as the 2-person team project. I would mention, though, that you could do parts of this as a 1-person project as well, if this seems like interesting to you. So conceptual modeling, as I said, this has already been done with this data, but we haven't quite shown yet how this compares to modeling without our process. So we have this research process that we apply for creating this conceptual model, which we have done in the scope of a master's thesis that has been done with us. And so we want to know, how does this model now compare to a model created without this method, with normal methods that you would apply in software engineering. And so if this would be a 2-person team project, we could have 2 persons creating a model independently using different methods, then comparing the results and writing all that up in a research paper. If no one is interested in doing this collaboratively, we could also just do the part where you create the model without the method and then compare to the results that we already have. So that could be done as one person project then as well. So these are, and everything around this concept of using this qualitative research methods and applying it to software engineering, specifically maybe requirements engineering, modeling, that's something that I'm interested in. And if you have similar things in mind or think this is of general interest to you, come to me and we'll find a topic for you. Thanks.
All right, so that was all of yours.
So now I just need to be careful that I don't strain the cable. I think it should work. So to give you a little bit of context, I'm doing research on inner source. Inner source is a software development approach where you try to use practices from the open source world, from open source communities within a company. So a company that uses inner source does not necessarily develop open source software, they might just develop proprietary software, but they use practices that can be found in open source communities as well. We came up with a couple of topics that might be super interesting for you. The first of them is regarding a classification system we developed, topic number 4 in the list. So we developed a system that describes what are different characteristics of open source, of inner source projects that can be found in companies. And now we would like to know actually how prevalent are these different classes of inner source projects we identified. So what a student would do in project number 4 is design a survey that would query software companies that use inner source about which classes they actually implemented. We have a long list of these companies, so the successful student would send out the query and also, depending on how we decide to do it, analyze the results of that survey. There are some variables here, depending on how many students are interested in this topic. There is the option to split that topic into some smaller topics. So then there is topic number 5. Yeah, we are talking to a lot of companies and we never really know, well, how successful was the inner source adoption at this company? How successful are they running inner source? And so we would like to learn what actually constitutes a good inner source program. So what are attributes of a healthy inner source adoption, inner source implementation? So in project number 5, the student will talk to some experts in the field and do perform interviews and qualitatively analyze them to develop a model of inner source health. Yep. And topic number 6 is also mine, right? Mm-hmm. Yeah. That's not related to inner source directly. It's a topic regarding how companies get involved with inner source. So what has happened here is Dirk performed a study that showed on a very large scale that company involvement in open source projects is massive, I would say. And we want to study that phenomena on a more fine-grained level and learn what is the patch flow between companies and open source projects that will be based on repository mining. The student will not have to develop much code to do that repository mining because we already have a framework in place here, but will basically analyze repository data. Now I'm wondering if I should also talk about the bug tracker things.
So this is a project, not on this.
Exactly. So in addition to the 3 projects I talked about, we also have a set of bug tracker or issue tracker data from a lot of open source projects. So basically all projects on GitHub plus I think the Apache Foundation. So if you are interested in doing a 10 ECTS project but do not find something in the list and you are additionally interested in open source issue trackers, then you should probably just come see us after class and ask about those projects. Yeah, that's it.
Thank you very much. So let's see whether I can get this back to working. This is just weird. Okay, that should work. So thank you guys, and for Anne as well. I'm logged out. And there's one more project, and please so pick some, and if there's double allocation again, we'll split it. One more which I added, SP7, which is of interest to another PhD student who's not actively participating in this course. It's about collaboration in knowledge projects. So Wikipedia is a knowledge project. There's lots of knowledge being built there, but we believe that this is last generation. And now we want to work on distributed knowledge projects where you work more like you work on GitHub. So Wikipedia, talking to open source people or software engineering people, is a centralized repository. We now want everyone to have their own copy that they evolve independently. So we have distributed, decentralized knowledge projects where everyone can have their copy, but then also, like in Git, make informed merges where you join things again. And the question is, how should people collaborate? If you have multiple people working together in a distributed knowledge projects, what is it? What are the primitives of collaboration? Is it like in software engineering, commits and checkouts, or what's the workflow? And to understand that, we also need to do a literature review and build hypotheses from reading the literature as to how this could possibly look like. So this is qualitative research, does not involve math, but does involve reading, does involve so-called qualitative data analysis, meaning an analytical annotation process of text to derive a theory, which is something we'll be teaching you in class because it's important, and that will be applied here as well. Okay, so this is it for the research projects. Those who would like to do one, please contact us if you haven't been in touch yet. We can directly pick the name. If you can find it through our website, it's very easy. Or you just use our general email address for this course, which is osr-nyt@group.rile.org. Maybe you'll type it into the chat window, but this is the same email address you'll find on the slides as the alias for the teaching team, also on the course index slide. Yes, please.
Is there a limit of students who can write about one student?
You mean limits to the number of projects we are doing? Yeah. Yeah, so we will, so first of all, after you leave this room and think about whether the workload is right for you, we will know then how many projects we really need to find. We will make an effort to let everyone, to give everyone who wants to do 10 ECTS, to give them a good project. So most likely it will work out.
So it's not possible that two persons are writing on the same.
Oh, jointly. Depends. You need to talk to the person handling the subject. Maybe it can be split up. Maybe it can be done, can be joint work. It's perhaps possible. I don't know. It depends on the topic. If you have some other person you love working with, you're really good. And
The question was, we don't have to work together, but
redundantly.
both the same way.
Yeah, we will probably suggest slightly alternative topics because what's in it for us if we have redundant work being done? We can, of course, double check you or make each other, run each other against you, or we make it a replication study or what have we, but we most likely suggest slightly alternative topics then. But don't be shy telling us what you're interested in. We use this as an indicator to work with you, what would be a good project for you. Yes, so that's exactly where we are right now in terms of the slides. Any other questions? So this is a particularly important slide deck. I realize how much information we are throwing at you. So we've tried to make it as easy as possible to not miss a beat and understand of what we expect of you. So course slides number 4, the course schedule, shows you the homework and preparation work you're supposed to do. Here's an overview table of the topic being covered in class in the content column, an overview of the homework for 5 ECTS due in a given week, and the deliverables of the project work in addition to the homework for a given week. 02 course week, 02, the second course week, meaning next Tuesday, the second week, next Tuesday, due by 2 p.m. before the class, is a first summarizing experience, but also your project decisions. So we have now a week to figure out what project you want to work on. So if you want to do a project, you need to work with us, and then you will submit a paragraph where you're saying, I want to work on X, and I believe the research question is such and such. Here we go. When are things due in a given week? Right before class, as just noted. The submission of your homework goes through course index, homework assignment links. Always go there. There you will see how and where to submit. Could be CrowdGrader, it could be stood on. I think you may even one time have to submit by email to us. What was due before class today? Nothing. For the 5 ECTS. What was due before class today for the project, 10 ECTS version? Nothing. We did engage in a conversation already, but it was not a formal deliverable. Next week, by 2 p.m. before class, we expect the following of you. You should be prepared for class by reading 2 papers, F74 and T14, which are reasonably easy to read papers. And it's not just required reading in this case, it's also required that you write a summary, a half a page to 1 page summary of each of these papers. So in total, you submit 2 papers as 1 PDF, please, through the link in the homework submission links spreadsheet, which in this case will lead you to CrowdGrader. So you read this and you summarize it and submit it as a PDF. And the way you summarize it is, for this coming week, is left to you. So you should think about how on earth can I get a 3-page paper, the Feynman paper, down to half a page. You read it, you should try to find out what's the essence, what needs to be summarized, how do I communicate it, and summarize it in half a page to 1 page. Be reasonable, don't use 2-point font, use 10-point or 12-point font, so don't play any silly tricks. Just try to work hard on getting to the essence and presenting it well. These 2 papers are PDFs you will find in the course reader. Again, there's a link through the course index to the course reader. Sometimes there is suggested reading. The DeMillo et al. Paper, that's actually quite an important paper for computer science because it really clarified some misconceptions that are still can be found today about the role of mathematics and software engineering. If you absolutely don't care about software engineering, you don't have to read it, but the point here is a clarification of what mathematical proofs actually mean to computer science and reliable software. Because still in school today, university today, I don't want to talk about our university, but simply wrong notions are being taught about the role of mathematical proofs. It's an easy to read paper. It's not very long. Well, it's reasonable. It's okay, but it's quite important in the history, I believe, of computer science. That's the homework. And then if you are also doing the project work, here's what what's due, simply a PDF with your project decision. You really just write one sentence. I want to research a research question of I want to create a model of episodic volunteering behavior. I want to find a hole in current research on episodic volunteering. So that's due for the project work. And the slides here continue giving you for every week what's due then. So due in 2 weeks before class, meaning course week 3, is reading one paper. This is actually a longer paper. This is considered a seminal paper, meaning a very important paper for information systems research. Quite frankly, it's also a hard to read paper. I would not give it to you if it wasn't so important because it's hard to read. But try your best at it. By then, I will have taught you a summarizing and extracting method. So you'll know how to approach this paper to get it down to half a page to 1 page. If you want to keep going, there's addition, and this is required reading. So this then is papers you read. You do not have to summarize them. You just read them. Probably you should take some notes and come prepared to class so that you can discuss it in class. Because what I will be doing once class starts in course week 3, I will be discussing these papers to make sure that you read them and that our understanding of these papers is the same. All the papers are either educational papers, textbook papers teaching your method, or considered important paper in our discipline, so important for something, so you should have read the original paper on the meaning of proofs, for example. And then the required summary, you submit it to the homework submission links, CrowdGrader again. But also that week, you look at the summaries from the previous week on Feynman and Tiki, and provide your 1 to 3 paragraph feedback to the other students, just like we are doing it. Next week, so project weeks, nothing due. Project weeks has deliverables every 2 weeks. We didn't want to make it every week. All comes week 4. 1 paper is required to summarize, how to write a literature review. Because I really want you to read that, because a literature review doing related work is key to any research endeavor. And then some easy reading. And then again, submit your homework, review prior week's homework, and give thumbs up or down to the reviews from prior week. Course project work, the first paper outline. The outline is easy because we'll exactly tell you how a typical paper looks like, but try to come up with good headings, put some first content there. Specifically, we want you to think of a good title, put down your name as an author, and try writing the so-called abstract, the 1-paragraph summary of what this work is about. So don't be shy. You do not know yet what your work will end up to be, what the results will be. So what you'll be doing is you'll be projecting into the future. In some sense, you're fantasizing. But that is actually good as long as you're not trying to submit it to a journal as finished work. No, it's work in progress. So you are trying to visualize, trying to put in words where you are going. It's a steering mechanism. You should be doing that, knowing full well that you will have to change it because it doesn't play out like that. But just by trying to project it, what you're doing, you are better understanding where you're going, and you'll be more likely to be more successful. Come this second deliverable, you should start using this particular template of formatting for your homework, for your project work, and on and on and on. So there's still one more required summary, meaning you need to summarize this paper, and then some reading. This is actually important reading because it really helps you structure research work. And then no project work. Here it only looks like a lot, but it's easy watching, and it's only reading and watching required. No summaries are due. So come week 6, you need to prepare by reading something, and in this case, watching some YouTube videos as well. And if you're really into it, you can also read some additional work. But the summarizing is winding down. So that week, you still need to do the reviews for prior week, but you didn't hand in a new summary. So it's winding down in steps. And we are switching to method exercises. So first we did the summarizing. Now we're into the second third of the course, and there is some methods to learn and apply. So my PhD students will guide you through that. There's some simple thing to be done here. Take a survey and submit the first exercise. What that means will be taught in class by the time this is coming around. And the project work also progresses. This calendar week 6, you should have been doing some literature review. What have other people done? What have other people done in the context of your research question, so you know the related or prior work that has been done, you submitted. And so I don't think I need to go over every slide here. By the time you're getting closer to that week, and once you enter that week, on these slides is spelled out exactly what I would like you to do. So we are trying to make it as easy as possible that you don't miss anything. We hope we have done this well. If there are questions, ask in the forums or ask us directly. Anything to add, Andreas, Max? You tell me if there are questions online, because I'm not watching the chat window. Good. All right. And we are at, where are we? I think we are ready for one more or the final research example for today. So let me take a computer science research question and walk you through a somewhat larger example than the slightly silly but hopefully fun cow milk example. This one is a software engineering question. And I want you to understand the structure, in particular for those who are doing a project, but also for a final thesis, because it's always the same. We're doing, again, confirmatory research. In class, we'll be doing qualitative, meaning exploratory research, but here I chose something strongly data-driven to answer as the method of choice to answer a research question. So we are addressing the lower half, the second part, because we already have a good research question in place here. Yes?
There was a discussion online where someone asked, with a coding exercise, would you actually need to code something as in programming? Do you need programming skills? And what we mean by programming in this context, coding exercise is not programming. So you don't need any programming skills for this course.
Yes, thank you. So what Andreas said was that the coding exercise, the word coding there does not mean programming a computer, but it means annotating text, more or less. It's a research method to distill a theory from some literature you read, interviews you made, etc. And so it's not to be confused with programming, even though sometimes you call programming coding as well. It's two different kinds of coding. Okay, so the research question we chose here because usually students who love statistics are underrepresented, so we want to encourage that because it's so important for research, and we chose a somewhat math-based project research example. The coding exercise, however, as the method exercise of choice for this course, is actually a qualitative one. You don't need math skills for it. So the interesting question is this phenomenon of open source, people working for free, is that alive today? Yes or no? And will it stay alive in the future? Can we know? That's actually quite important. All software on this machine here, almost all, is open source software. That's my workhorse computer. I would like to know, is the software Will it be maintained? Will it be developed further? Or will we all go back to Microsoft or something else? So from a general research question, which is typically too generally to be answered, we need to go to more specific research questions, or in this case, hypotheses. The hallmark of a hypothesis is that rather than giving a long-winded prose answer, you can answer it with yes or no. So it's a binary answer. A hypothesis is a particular type of question that you can answer with yes or no. And I break down this overall research question into these two hypotheses. Is there at least one active open source project, meaning it's alive, even if only barely? And for the purpose of will it stay alive, I equate this with it keeps growing. If open source keeps growing, there's more and more activity, then we can conclude it's alive. So I'm taking something much more specific to answer a more general question. You can debate whether these hypotheses adequately reflect the overall research question. I believe so, but that's the human element in science. If someone disagrees, we can discuss it, but I believe this is a reasonably good specific set of two hypotheses to answer the overall question, if evaluated. So here's some pseudocode. I'm not even sure any longer why I used that, but I wanted to show, I guess, to computer science students a structured representation. You can see the scoping of how the very general question, open source is alive and will stay alive, is broken down into two parts. Is it alive today? Is it alive in the future? And how I frame is open source alive today? Yes. Also, is there at least one project? And there's nothing that speaks against our finding that there's at least one alive project. That's for is it alive today? And for will it stay alive is the growth of the number of active projects where people are working, is it larger than zero? Meaning there's always one more new active open source project and less are falling away. And then again, no other indications are suggesting that this is wrong. So we need to go, after these two hypotheses, we need to go into an operationalization. It was still words. What specifically do we mean? We always need to get specific. So we need to define terms like, well, what do I mean by active? Well, an open source project where there's one contribution in a given year, is that an active project? Yes or no? We just need to define it. And then other people may disagree, but we need to define it. If we don't define it, it's just words, and we will not get it published. So we chose a definition in line with other researchers. Our definition of an active project is where in a given month, if during the last 12 months, the number of commits amounted to at least 60% of the, oops, how did we define it? Sorry, I should have looked at this again. So a project is an active project if during the last 12 months, that's simply a typo, the number of commits amounted at least to 60% of the prior command. So you look at two time horizons and you notice that the most recent time horizon has at least 6% of the activity of the one time period, time horizon before that. So yes, we allow for a decrease, but only by 40%. Can you get up my my charger, please? And growth, how do we measure growth? Well, if we can measure the number of active projects over time, then the growth is actually the first derivative, high school mathematics. So if the number of active projects goes like this, we take the first derivative, and that's the growth of active open source projects. So now we need a plan. So we are more precise now, but that's still descriptive. Sure, we have term definitions now. You do need the, I'm sorry that I gave it to you. You do need a more precise plan in steps of how you get to data to fill the actual definitions. So which projects are we talking about so that we can say this is an active or not an active project? How do we know this particular project out of a population of projects is active or not active? Okay, I'm sorry, it's in here. So we do need to determine for a given project, is it active or not? So the question is, how are we going to do that? We may have a definition, but this doesn't mean we have the data. And sometimes you simply cannot get the data you were hoping to get. Then you need to do math. You need to align it over time. It's actually a time series. The project is active, 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 and maybe then it's dead. So you have this time series. At what time horizon do you see? And once you have gathered all this data, this is all just preparatory work. You actually need to apply the math and apply your hypothesis as to over time the growth is larger than 0, for example. And that will eventually give you the answer to whether your hypotheses are true or false. So this is the plan. How do we act it out? Well, we try to use as many tools as possible. In this case, there's a service out there called OLO. Actually, now it's called OpenHub. And they gather the basic project data. So it could have been that we needed to go out and determine the population, meaning all the projects we want to look at. And then for each project, go to the website and look at the source code, and look at the activity. In this case, we are fortunate that we have a collaboration with this particular company, which provides us with the data. So from this company, we already get a large number of projects with the activity data that we can then build on. How do we build on it? We are now into the mechanics of carrying out the research plan. Well, we have the raw data from that company, but they gave us a big data dump. There's lots of data in there that we were not interested in. So we somehow need to extract the data that's relevant for us. Now we have the relevant raw data, and then we prepare it and massage it in such a way that we can apply our statistical tools, meaning evaluate the hypothesis on top of it, and then we'll get our results, maybe visual results, maybe a true or false statement of hypothesis testing, etc. In this case, it actually means writing code. There's a database you can get to using SQL statements. The tool of choice in this case is the so-called R project, which is a software for statistics. It's an open source software. It's widely used, has lots of software packages giving you all the math functions you need. And you write code we wrote code, or specifically Gottfried, a former PhD student of mine, wrote code to get to this data and put it into a time series form where we ultimately would see a large number of projects. For each project, for a given time point, whether the project was active or not active. And so, okay, so I actually jumped ahead. So get to the number of projects, just figure out which projects we can talk about, and it should be representative of open source ideally. Then for each of these projects we found, determine the project states, meaning is it active or not. Well, this is literally a series of tuples where there's a project ID, project name. We choose a time window of month. So on a monthly base, we measure whether it's active or not. Could have taken days, but or weeks or years. We took months as a reasonable granularity, and then active or not active. And so we walk through it. Here we visualize the number, no, it's actually the first derivative, the growth in open source. So these are the number of new projects in our database, which is a bit zigzaggy, meaning we didn't smooth out anything here. It's a raw data chart. But you can see already from eyeballing, without doing hypothesis testing, that the growth is actually accelerating. And hinting at our hypotheses are likely to be true, which of course makes us happy. So, but that was just a charting visualization of the raw data. You still need to do the mathematical hypothesis testing, and we did that. In this case, the first hypothesis becomes obviously true because there's an increasing number of active open source projects. Certainly there's at least one active open source project, implying open source today is alive. And then when we looked at the growth, we actually, in real serious research work, of which this is a simplification, we modeled this particular growth. See, what scientists want to understand is not only is it alive, we actually wanted to model the growth. We wanted to see is there a closed analytical function behind this. And indeed, the nearest or the best approximation of a broad array of functions that could describe this growth is, fortunately, exponential growth, which has the benefit of knowing that the first derivative is also exponential. And why do I not get charged? We know it's exponentially growing, which implies that the second hypothesis is also true. So we get to the overall combination, and we can say open source is alive and will stay alive. Are there any questions to that? If you're a very careful observer, I did skid around certain corners, so I would not be able to get this published like that. I took some shortcuts, but I think to give you an idea of a full run project, this was good. This was would be more than what you can do in your 10 ECTS project here, I think, because you don't quite see it, but there's a lot of legwork, meaning something that takes time in the data gathering and analysis. Just running a statistical test is not a lot of time, but the data gathering and massaging, that's the big time sink. All right. And I want to do one more slide deck, and then I think we're done for today if my machine holds on. This was the research work that we did, and it still needs to be provided in presentable form, meaning we need to communicate it to other researchers. So I'm giving you a simulated, simplified research paper based on the work I just showed you. And what it means is all these research papers have the same structure. There's a logical flow to it, to a research paper and to a research thesis, or good bachelor, master thesis, because these different sections of presentation build on it in a certain way. And even though it's bad, if you will, reviewers, people who read your work, including professors who read your final thesis, work with a lot of pattern recognition. So they see if you don't know this, you may not be following certain patterns, which may lead to the reaction, no, they didn't get the logic right. Because if they got the logic right, they would be following these established patterns. So you need to know them, and if you want to deviate from these patterns, be very explicit why you do that. So here then, this is a paper structure by percentage, the different sections. You need a title, you need an author list, abstract, meaning a summary of what this paper is about, very short, one paragraph. You need an introduction, which tells the world what's the overall problem space you're in. It's a motivation for a reader, in addition to the abstract, a motivation to read on. You then need a related work section, typically following the introduction, where you're saying explaining what other people have done. You're talking about other people's work, and thereby you're demonstrating you are at the state of the art because you know what other people have done, so that the work you are now going to present will actually be an advancement over what's already there, which implies good research. After that come the actual contributions. It's another one of these artificial terms, the contributions, meaning the work you did and you want to present. And this is typically at least 3 sections, split up in some theory part, or the research question part, or the method. You take then a validation part, or a discussion part, or where you present the actual results. And finally, limitations or critical reflection, depending on what type of work you're doing, where you actually show not only have you done good work, you just showed this in the previous sections, but you also know its limitations, because no work is perfect. So there's always some shortcuts, some things that may be limiting the generality of your claims, etc. So without critical reflection, people will think you're trying to pull a fast one because you don't understand the limits, because there are always limits. That's not a good thing. And you finish the paper with conclusions and some acknowledgements on maybe help you got, and of course the set of references, the literature. Andreas, can you move forward 1 page, please? Yeah, I'm out of juice, other direction. All right, so let's take the example, and what's a good title? So we'll walk through this later in the course again, but just to give you an idea and have those doing the project with us, a good title could be, is open source sustainable? The answer, the work we are presenting and what you just saw is more specific. Sustainable is a somewhat vague word. It's also a bit of a fashionable word, but it does show by that way why it's relevant what you are presenting. So I think is open source sustainable is a good title. You could also have a more specific title like is open source alive, or you could turn it into a declarative statement, open source is alive and kicking. Well, maybe not that, that's too casual. You can experiment with that. We'll get to quality criteria for titles because they are super important in the second half of the course. Next slide, please. The author list looks like this, just your name, your affiliation, meaning where you work, and ways of reaching you. I think postal addresses are not really needed any longer. A web address, an email address is all right these days. Go ahead. So here's an abstract. That's actually an actual, this is an actual complete abstract. We will see patterns of writing this abstract. Like the title, it's super important because this is how your work gets perceived initially. So it draws in the reader or not. It's how it gets indexed in libraries, meaning how other people will find it, other people who are doing their related work section. So spend considerable time on wordsmithing your abstract. So open source is available for free. So we are providing context. Where are we? What is open source, etc. Now comes the problem. Open source managers worry that it's temporary and will go away. So creating problems if you are somehow dependent on open source. Oh, that's a problem. Yes, that's a problem. Can we help solve that problem? Well, it's a worry of managers. So this article analyzes the growth of open source and shows it keeps growing. Is that an answer to the worry of managers? Well, yes, we are showing by way of showing this that open source is a sustainable phenomenon and managers need not worry. So in the abstract, we have both shown or mentioned the actual result as well as its significance to society or within a disciplinary context. If we had only talked about the results, someone might have thought, who cares? If we had only shown the worry of people, yeah, they would have said, that seems important, but what's the answer? if they don't have an answer, because otherwise it would be mentioned in the abstract. Go ahead, please.
I have a question.
Yes, please.
Would an abstract like this be sufficient as a summary?
So abstract and summary by and large means the same for a research paper. And so that is a good abstract, actually. What's coming now are shortened versions of the actual sections, but that abstract was a reasonable abstract. So we are now into the introduction section. As you can see, we are taking a step back. Where are we? We are talking about open source. Why are we talking about open source? It's economically important. Okay, why is it economically important? List of references, other people who have stated that open source is important. So we're relying on other people. We are building on the shoulders of other work. So, and then starting with, this is this context, we zero in on the particular research question we want to answer, leading up to why that is an answer-worthy research question. Why do we care about this? Why is it important? So we show in the second paragraph, despite the success, some still worry for this and that reason. So there are counter-arguments. There are people who claim open source is dangerous to rely on. So we want to know, is that true or not? Or can we show, no, it's not dangerous to rely on? So we take a constructive approach. We don't show it's bad, we show it's sustainable. So we zero in on our research question and simply state the results. We show it's sustainable. And in the context of an introduction, that is really just the claim. The paper is there to show that this claim is true. But in the introduction, we are making the claim as to what the paper is showing by way of its later sections. And then comes an idiosyncrasy of research writing. At least in computer science and information systems, you are well advised to be very explicit as to what are you delivering as the so-called contribution, as the advancement of the state of the art. You really find in almost all articles now this wording. The contributions of this article are, and then a bullet list. So this speaks to the pattern recognition of reviewers. What is it that's new here? Some people, some reviewers, if they are particularly short on time, will just skip everything. They will assume they know the domain, they know the problems, they want to know what's new. And the most succinct, most precise version is this bullet list of the contributions of this paper. And then comes an explanation typically of what's to follow in the follow-on sections. So it's highly patternized how a research paper like this looks like, and you can carry this forward into your final thesis as well. Next slide, please. So after the introduction, now comes the legwork. The first part of the legwork is you know what has been done before you. So you're not God, you're not inventing everything, you know you're building on other people's work. And that's the related work section where you show two things. You understand the issues in the domain because in the related work section, you actually compartmentalize philosophical from economic, from sociology issues versus qualitative research, meaning exploratory research from confirmatory research. You have a grasp of the domain and the different types of answers that have been given to related questions. You lay it all out. It's easily a page or two where all you do is other people, all you say is other people have done this and that. And typically then pointing out, but they fall short on this. So you will mention the weakness typically of other people's work because, or with a focus on, and your work is going to fill that hole. Because that's giving, the related work section not only shows your competence and that you're at the state of the art, a true peer, it also shows and motivates there's a hole in the literature. Here's new work, and we are delivering this new work. So with that, then you can get into the actual contribution. Next slide, please. Thank you. So the next three sections vary, whether it's exploratory research, confirmatory research. Here I chose confirmatory research, so you already have a theory. and you just explain it. So maybe in prior work you did exploratory research, you came up with a theory, you don't know yet whether it's true, but it's likely to be true because you did good qualitative research. So now you have a theory and you explain it. And in this case, it's really just these two hypotheses that would answer the research question. You provide an operationalization, meaning you define the terms precisely. You're just laying out things. Here, the theory section is really just definitions and terms, as if you're preparing a mathematical proof, even though it's not a mathematical proof. Next slide, please. Then comes the actual application of some research method. Sadly, for students, you only present the results. If it was to reflect where you spend the time, the large part of the writing would be, and then I programmed the code to get to the data, and the next few weeks I fixed bugs in my code, and then I ran it again, and then I fixed more bugs, because that's where you spend the time. In research, only results matter. For a final thesis, a professor can be lenient in the sense of, oh yes, I know how much you suffered because you had to use this bad other students' code, etc. So you'll get some bonus points for effort. In science, in research, only results matter. It doesn't matter that 90% of your time was spent programming some data access code. Only the results matter. Yes,
There's
please.
a question online saying, is it possible to include related work in the introduction part? I'm just wondering because I'm used to different template for papers.
Okay, so I'm not sure the other students online. Let me repeat it. So are there other templates? Of course, there are other templates. One specific other template might include related work in the introduction section. I have not seen that. I don't know which discipline that student is from. Did he say, she say?
Biology.
Biology. Yes, so I don't know much about biology papers. Maybe they put it together there. So that would be in the discipline of biology an accepted format. So you would talk with your professor and they would know. In computer science, information systems, related work is always separate from the introduction. I've never really seen it merged. And since I'm not a biologist, I don't quite know the reasoning for merging it into one section. So in the second section of the contributions, you typically apply a method, you get to the data, you really just present the results. You don't say how much you suffered, though everyone will understand that. You really just present the results like, say, this model we found for the growth, and from that we can conclude that our hypotheses are true. Next slide. So then, finally, you need to discuss your findings. This section has various titles, from critical discussion or review in a more exploratory/qualitative paper, all the way to threats to validity in a highly data-driven confirmatory research paper. You discuss the limitations, and depending on your content, you walk through those that you are aware of. Like, is it representative in this example? Can we really talk about all of open source? Did we get all open source projects? Probably we did not, so we did not in this case. So now we have a subset. Is that representative of all of open source, or did we just look in the right place, which we happened to find by intuition because that's where we wanted to look to, and we just did improper work? So you need to discuss these things. Is it representative? Can we generalize? Are there limitations to the representativeness? Were there any issues with data quality? Maybe there were some problems. Maybe in the year, random stuff can happen. In the year 2003, maybe the data is bad. All your data is good. 1995 to 2002, 2003, something weird happened. 2004 onwards, it's good again. Can happen for whatever reason. You need to disclose it. That's scientific honesty. So you discuss all that and the impact on the actual conclusions that you want to contribute to the state of the art. Next slide, please. And then in the final conclusion section, you repeat the key findings. You just say again, typically, what you found, because readers read your paper a certain way. They might go from the title, an abstract, they might actually go right to the conclusions, just to see what actually came out at the end. So they see the claims early on. At the end of the paper, do they still say that, or are they trying to make me read a paper that's not worth my time? So in the conclusions, you repeat your key findings, and typically also say something about future work that you want to undertake, conclusions you see, consequences you see of your work for other research, future research, other researchers, etc. And well, you also have to say, and thank you to whoever helped you. In this case, I simply spread it like this. A PhD student of mine helped me by preparing the data. It depends on the context. Sometimes this will make someone an author, co-author of the paper. So it's not just me, it would be him and me. Sometimes it depends on the contribution. It just leads to a thank you and the acknowledgement section. It depends on the extent of the help and contributions and whether it's considered substantial intellectual contribution to the paper. In this case, I certainly would have made him an author of the paper, but I needed something to put in the acknowledgements. So it's an example here. This is not a real research paper. Next slide. The references, so here were 2 papers we referenced. They need to have a certain format. There's a way of indexing it. We will discuss all this in some of the next sections. Next slide. I think we're done. Yeah, that's it. So that was a lot of information today. Yes, please.
I have a question, and it's about this template for data. I see the advantages you have from having short introduction basically, and all the targets for or the goals for this paper and the results at the end. But as you said, there may be people that just read these 2 parts and skip everything else. So, should we consider doing something else instead?
So we didn't talk yet about if this was a real research paper, what would happen next. What would happen next is you submit it to a journal, for example, where it will get reviewed, and the template is to minimize the likelihood that the reviewers will not get it, what you're saying. The likelihood is actually, despite your use of a template, some reviewers will not get it. This so-called peer review, which we will discuss in the second half of this course, is imperfect. It usually needs multiple tries. Using a template is an attempt to minimize the likelihood that things go wrong. Do you always have to stick to the template? Of course not. It's a suggested template. When should you deviate from this template? Well, if you are experienced. So we are in a class here on where most of you are just taking the first steps in research. So I view this as Stützräder, as helper tool for you to get your first papers right, or help you write your first papers in a way that it makes sense to reviewers. Typically, that's my recommendation. You should start experimenting and improvising once you know what you're doing. As you're just learning, you should try to do it by the book, meaning follow these templates. Yes,
There's
please.
a question online asking, is the template presented now equal to the ACM template linked previously? And is this suitable for a master's thesis?
So thank you for that question. There are 2 types of uses of the word template here. The ACM template is really just formatting. What font, what heading, that type of template. And while it has a few example sections in there, they don't mean anything. They happen to have an abstract and an introduction, but it's not a full paper template. Our template here is content-oriented. What's the actual content, this actual structure of the content? It doesn't tell you anything about the font. So it's 2 very different uses of a template. And then finally, for your master thesis, We finally decided, after 5 years of experience with students like you, that we classify our final theses into different types of theses, which have different templates. You can still change those templates. You'll find them on our blog, but they're depending on what type of work you're presenting for your master thesis. If you have a hardcore research thesis, then actually it will look like this. If you have more of a classic engineering thesis, then it will look different. Which actually brings me to those people doing their research projects. Of course, from our perspective, we hope this will be real research that you can also take forward into a master thesis, though that, of course, is not required. Any other questions? Yes, please. Mm-hmm. Mm-hmm. Let me answer, and then you tell me whether I actually got your question right. The abstract in a research paper, as discussed here, is also a summary of the research paper, but it has additional reasons of existence, most notably motivating people. So you do write it a bit more sexy than like your method section on hypothesis testing. And it's for research paper. The homework summaries for the first 4 weeks are really just summaries of what you read. And so they can be more dry, and they're really just a summary. They are not leading into a paper. So it's, in my opinion, a different type of summary. Really what an intuitive notion of summary would mean, what's important about this paper I read, that I need to communicate to a reader here. That's the homework summary. It's not the abstract of a paper. So the homework sometimes, but not always, has an abstract. And yes, you can use that to get to what's essential about the paper, and as a consequence, it will influence your own summary. You can do that, but your summary should be longer than the abstract of the homework reading if it actually has an abstract. Mm-hmm. Any other questions? Yes, please. Mm-hmm.
We have already built a survey where we don't have to contact you, but the respective which we think will contact us.
Yeah, well, I recommend you do send an email reconfirming your interest. We did this as a test to simply see how many projects do we need to put out there. We guessed 10, so we've got 15, which is great. So we need to do a few more. Please reconfirm that you're still with us. All right. So that was a lot today. Please look at the slides. Please don't be shy asking questions in the forums. And I hope to see you next week.